Hi. They always give the after lunch talk to someone that has too much energy. I could tell when Michael and Francis were up here, they're both very measured gentlemen, and they probably had the thing in their heads before the keynote, like, okay, up energy, up energy. And for me, it's like, okay, Kevin, slow down. Don't lose folks. Hi, who here would consider yourself a Flutter developer? Okay. Who would consider yourself a Firebase developer? And if I say Docker, who knows what I'm talking about? Oh, that's great. Who's actually deployed like a Docker thing to the cloud and run code in the cloud? And who has no idea what I'm talking about with Docker? One? Okay. I might go faster than you like. We'll cover things in a bit. This is me. So my day job is web tech for Flutter and Dart. And I do mean the end-to-end stack. So our product management team generally focuses on platforms. I'm one of the weird ones who actually covers both the Dart team and the Flutter team on web stuff. So I'm not an engineer, at least in my day job. I pretend to be one at nights and weekends. So our two JS compilers, our WebAssembly compiler, which we're working on, very excited about that. Our browser libraries, Flutter and web integration, that's kind of my product ownership area. I'm not going to talk about any of that today, although if you have questions about Dart and Flutter on the web, come find me afterwards, happy to chat. And I'm KevMoo pretty much everywhere. So Twitter, GitHub, Reddit. And my weird vanity domain is j832.com. And if you're curious what that means, again, ask me later. But that has links to all my social media and all the random videos and podcasts I've been on. Almost every app needs a backend, right? The example I gave forever was the chess timer app I had on my phone when my kids and I would play chess. It's always bad when your kids start beating you at chess. You're like, oh, you're learning faster than I am. But my chess timer and maybe the calculator, I think, don't have a backend integration, but pretty much everything has backend integration, right? And of course, we're here because of that, right? Like Flutter and Firebase are a great story together. It's cool to tell the story about how our teams are working to bring just great app experiences. It started out with mobile, but obviously now desktop, web, other places, bringing great experiences to everyone. And so obviously Flutter is all about the pixels on the screen. Firebase is all about the backend. Three technologies I want to highlight, and I'm sure most of you are familiar: Authentication, Spectacular, and Firebase. You can do anonymous, Twitter, GitHub, Facebook, Apple, I think too, right? Like just all the auth methods, super nice, having consistent API for those. Firestore, super cool, scale to 0. Actually, I finally realize now when people talk about serverless, that's really what it means, right? Which is you don't have to think about your instances. So you can leave your Firestore database up, and if no one's hitting it, you don't pay for it, which is just great. I also find this is the only storage-related emoji I could find, which is like the phone, right? Like the hang-up phone. No one uses that type of phone anymore. It's like the newer kids are like, oh, like someone 3D printed a save icon. Like, have no idea. Is anyone old enough to remember 3.5? How about 5.25 inch floppy? 5.25? Anybody? Okay, good. I'm not the only child of the 90s here. And of course, hosting is super cool. And what's great about Firebase Hosting, again, as a web person, they handle all the CDN stuff for you. So making sure that you use Brotli compression, which is the industry standard compression for your content. It's super easy to wire up Flutter Web to deploy to Firebase Hosting. And then they actually have some cool integrations I'll talk about here in a bit. So my scenario is this, which is, as I mentioned before, my energy tends to be on the high side. I'm actually working very hard, especially realizing I'm not speaking in front of necessarily everyone being a native English speaker. Although even in a room full of native English speakers, I tend to go pretty quick. So I built this app, Fast or Slow, which is to give me feedback about how fast I'm talking. And so, in fact, if people want to load this up, the few people with a laptop open, you don't have to if you don't have a device open already. I'm curious to see if this increases as we go. You can see I can change a score here. Let me zoom in a bit. I'm curious to see if someone else joins, the count should increase here. Oh, there we go. Some people are joining in and changing. So on average, it seems like maybe I'll say I'm going a perfect 5, perfect in the middle. It seems like everyone else seems like I'm doing a pretty good in the middle job. So clearly, I have a piece of Firebase Flutter UI, right? A scroll, a slider with a counter, and then the bottom is some aggregation stuff showing like what the opinion of the group is. And so right now, Firebase does support aggregations. the aggregation it supports is count. I think there's another one. Count is the only one you can do right now. So you can do an aggregation query with Firebase, but count is it. But we want to do more, right? We want to do what's the minimum value, what's the max value, what's the average, to be able to get those values across a set of answers, right? So really what we want is compute. I want to be able to take the interactions I do in Firestore. There's obviously a lot of interaction and a lot of flexibility you can get with Firestore, but I want to be able to do arbitrary compute. And ideally, I want to do it in Dart. So I'm going to stay in the same language I'm using to write my front end, I can write my back end. Please, let me do that. So I'm sure a lot of people are like, oh, clearly there's an answer, right? Which is Firebase functions or cloud functions. Is anyone else starred that request for cloud support for Firebase functions? I wish I had that for you today. Wouldn't that be a great, just aha? I don't. So there's a couple things. Dart is traditionally not seen as a backend language, right? So the cloud folks have done a bunch of work to support, PHP and Ruby and a bunch of others, and Dart just hasn't hit their radar. At best, it's considered a front-end language. And so part of what we can do today is, if enough people invest in this area, and in cloud statistics, they see that people are investing and using Dart in the back end, it helps make our case. So if there's any kind of call to action for today's talk is, if you're excited about Dart in the back end, use some of the tools I show here, some of the tools I'm going to reference other companies are doing. If we show that Dart in the cloud is a real thing, hopefully we can make the case and get support, because everyone at Google is busy, and so they need to prioritize. And that's kind of the first point I want to make, which is usually when you think of Dart, you think of Flutter, right? And not many other places. Dart is actually older than Flutter, and again, if you want to talk about the history there, I've been around long enough. I'm happy to chat about where Dart came from. But even in the Dart team, we use Dart for a lot of things. So first, the common front end, which is crazy to think about. So the Dart VM actually ships a bunch of code that is sourced in Dart. So I don't think V8 ships any JavaScript source. That's part of the V8 engine, but we do that with Dart. So actually, we pre-compile Dart code into native code and then embed that in the Dart VM. So the CFE, common front end, is the thing that actually handles parsing Dart language. So for a while, I think we had 3 or 4 separate implementations of the parsing logic for the language, which, as you can imagine, is a horrible way to have a consistent experience. We now have one on the common front end. So this is what's used from all the tools, not only the VM, but things like the formatter and the analyzer all use the same parsing logic for Dart. The pub CLI is also written 100% in Dart. So the analyzer and formatter are all in Dart, as is the pub CLI. Both of our JavaScript compilers, our new Dart to WASM compiler, all sourced in Dart. So these very high performance, high demand apps, like these are the apps that build these giant internal apps you have at Google, are all sourced in Dart code. In fact, there is a WASM library in the SDK. It's not fully supported, but if you're curious, you can go look. And we have Dart code that will generate WebAssembly modules for you. So if you wanted to go generate, have a nice typed API to generate WASM, we have a Dart API for that. It's not published, but you could at least go look at the source code, which is pretty cool. And then pub.dev, our server. And so I actually asked them, I was like, give me the number. And they said 5,000 QPS at peak. And so if you do the number there, that's about 400 million queries a day, or hits a day, all served with Dart on Google Cloud. So I'm not going to pretend that it's just magic. We scale out from a number of instances. It's not hundreds of instances. It's like in the order of a dozen, but we do scale that big. So in terms of enterprise handling, we can do that with Dart, and we've done it for a long time. And one of the really cool things, getting to the Docker thing that everyone understands except for Jonas here, you'll learn, it's really cool. The features that make Dart a great language for mobile apps, so the ability to compile to a native assembly, to a small native assembly that can start up really quickly, it turns out that's spectacular for cloud workloads as well. So you can get millisecond cold starts on container runtimes like Cloud Run with Dart. And so if you install the Dart SDK, it's about 800 megabytes. That includes things like the Dart2JS compiler and all those things. You don't want that as part of your image you deploy to the cloud. So what you can do is you can take your app, you can compile it in a Docker image, and then take that compiled image with a few libraries and deploy that, and you get about 15 megabyte container. And so now you can scale up super fast, again on the order of milliseconds, scale from 0 on cloud runtimes. And so just a great story of the things we did to make Dart great on mobile devices also makes it great in the cloud. So let's talk about Dart specifically on the server. I mentioned before pub.dev, 5,000 QPS, which is pretty great. There's a set of packages that the Dart team supports. We don't really promote these. We kind of consider them part of our tools offering. So it's best effort support for external issues, but we're happy to take pull requests and see issues. Shelf is just the main entry point, but there's a bunch of other packages we have around routing, static asset handling, a bunch of other things. So take a look at Shelf and the related packages if you're looking to get started. So this is built on top of the server APIs we provide in Dart by default, Dart.io. And what's nice about Shelf, it's designed for composability. So the API that we provide in Dart.io is basically we hand you a request, and then you need to go into the request object, find the response object, and edit the response that's part of the request. And that makes it really hard to compose. And you want to be able to take a handler or middleware and layer those things together. Shelf gives you that model. In fact, I named Shelf after Rack, I think, in the Ruby world. Does anyone know Rack, Ruby, Rails? No one. Wow, I'm old. So if you knew that world, it's based after Rack from the Ruby world. But there's a bunch of other offerings. So our friends at Very Good Ventures have Dart Frog. Dart Frog's actually built on top of Shelf and just adds a bunch of helpers and convenience things. ServerPod is a server framework designed to build backends for Flutter apps. And our friends at Invertase have globe.dev. So these are 3 companies that are building offerings targeting Dart on the server. So it's obviously not the focus of the Dart team, except supporting our package ecosystem. But there's a bunch of companies that have spent time here and individuals in our community who are excited about Dart on the server. And so hopefully people here will get interested too. Going one level deeper though is Dart, and specifically on Google Cloud, which if you're thinking about building backends and compute behind a Firebase experience, it'd be on Google Cloud. So obviously we have great support for containers. This is the offering, it's called Cloud Run. I have a tweet, I should have shared it here, but you can go, literally if you have a configured billing on your Cloud Run account or Cloud account at all, you can go from 0 to running a containerized Dart application, server application in literally 90 seconds. Like there's a button you can click on a sample and you'll be running in 90 seconds from nothing. We have packages to handle things like protobuf and gRPC. These are supported by the Dart team and some internal folks. We're doing a bunch of work to improve these as well in the next several months. Google API package is something that I maintain. That's based on JSON endpoints. And so I think there's on the order of 100 APIs here. So these are things like Gmail, Drive, Calendar for personal data, and then ML, what else is there? Spanner database, caching. Like there's literally dozens of APIs here to play with. And I try to keep this pretty updated as new APIs come along. There's a Google Cloud package, which is something else that I maintain in my free time. It's bad my boss is here to know all the work I'm doing that has nothing to do with Flutter Web, but a lot of people find this useful. This is actually convenience helpers, just making it easy to run in Cloud Run. Access stuff called like the metadata server, I'll get into in a bit. And then there's a function framework. This is not Cloud Functions, this is a separate thing, but this aligns with some technology called EventArc that will support a new model for how we do eventing. And so when I talk a little bit later in my talk about how we wire up and handle events from Firestore, we use a function framework. So, can we solve our problem? Can we do cool backend stuff with Firebase, Firestore, using Dart? We want to do this min-max average thing. The answer is yes. In fact, there's 2 ways to do this. I will cover the code to do it one way, and then I'll kind of leave it as an exercise to the reader for the second way, and I'll give you some good pointers to get started. But before we get started, I want to give a note. A lot of this is under construction. So the best talk to give, right? You go in and they're like, here's your 3 things to do, A, B, C. And they repeat it 6 times during the talk. You're like, I'm gonna go do A, B, C and it's done. It's nowhere near that. There are technologies across a whole set of stuff to cover here. There isn't a clean package yet. We're still talking to the cloud team about offering good things. But what's cool is I'm gonna go maybe 1 layer, maybe 2 layers deeper in terms of how things work. We'll talk about containers and doing builds in containers and doing JSON Web Tokens and a bunch of deep things. Don't feel bad if you don't get it all. The talk will be available later. My goal in this talk is I'll give you a link to the source code. I'm just going to fill you with ideas today, okay? You'll see a bunch of technology mentioned. You'll see a bunch of references to things. It might not all click now. That's totally fine. But when you go in and you dive in and look at the source code, you're like, oh, I remember him talking about this. It'll make sense, right? And then find me on Twitter, and I'm happy to talk through things that aren't completely obvious right away. So let's talk about the first way to do things. So that's using Firebase Hosting, which I already mentioned, how you host this app. So the app I have, where'd it go? I think it's here. Web.app, how I host this app now. And using something called dynamic content, specifically dynamic content in Cloud Run. So we're familiar with our firebase.json file, right? If you're doing hosting. This is all you do, is you add a rewrite section. And you say, source is API ***, or wherever you want to do it. API seems to be a good place. And basically what this tells Firestore is, any request to HTTP under API, route it to that service ID at that region. So be careful where you deploy Firebase and where you pick where you want your hosting to be, because you need to align this region with wherever you do your hosting, right? Likewise with your Firestore instance, you need to make sure these are all compatible. US Central 1 is great. I'm from Iowa, so I have a bunch of pride for the fact that the data center's in Iowa. And now what you have is, you have all the same hits to your server, right? Your HTTP requests, but some of them will go to Cloud Run instance. And then in my app code now, it's so funny, I watched Remy's talk about using the ODM. I didn't use any of that in my code, just trying to keep things simple. So I use some really weird listing and things. But all I do is I get the user object. This is again from Firebase Authentication. The example here is anonymous auth. And I do this request, get ID token. And that gives you a big, ugly string, which I'll show you in a second. And then I make a request to the backend. Now this is one cool thing already about using Firebase Hosting, especially if you're using Flutter Web, is I can just post to the local URL, just /API. I don't have to put a domain or a host in there. And what's nice about that is I don't have to worry about cores. Anyone dealt with the wonderful thing about cores on the web? Isn't it so fun? If you use Firebase Hosting for your backend, you don't have to worry about that. You're on the same domain. You can make requests. It just works. And then I set an authorization token, and I send the value to update. And is anyone familiar here with JSON Web Token? It's cool stuff, right? It's a little bit weird. And actually, I'm going to get into some of the details about how this all wires together and do a time check really quick. It's pretty cool. What you'll often see is a thing like this. Any questions? No, let me actually. So the first thing I wanted to show, if you run into this and you're like, what is all that? There's this great thing called JSONWebToken.io. Now, the first thing is, if you're doing a live presentation in front of an audience and having recorded, don't paste the JSON Web Token unless it's for a throwaway account that is anonymous login, right? Like, I'm curious to see how many in this room could actually, in the course of 30 minutes before this expires, actually go do something evil with it. But this is anonymous authentication. I'm not too worried about it. This is not my Google login, Michael. So it's actually, writing the parser for this is actually not too hard. I've actually done it myself before I found someone else's. So it's base64 encoded. You see there's 3 sections here, separated by periods. The dot there and a dot there. One just shows the kind of the algorithm to use. Then there's a whole payload. So you see this is an anonymous provider here for Firebase, where the issuer is, and the user ID. And then stuff about when the token was issued and when it expires. And then some signature verification stuff. And we'll get into that in a second, right? But that's all JSON Web Token is. So you take a bunch of JSON payload stuff, you encode it once with a JSON encoder, then again with base64, and you append it together. And then there's some crazy signature logic we'll get into in a second. That's a JSON Web Token. And what's great is I can now verify this cryptographically if I have access to the public key to make sure that this is signed by people I trust and it's a valid user. And I know that it's valid for this time span, right? And this gets important in a second. So let's look at the server code now. I've talked about doing this update thing, right? Switch to the IDE. And I realize we're all going towards VS Code. Is anyone else having trouble switching over? The keyboard, thank you. Parker and me are the only ones. Like, I will have to at some point, but it's tricky for me. So here's my update logic I mentioned before. Let's go look at the server. So if you look at the source code, I'll send a link to this later. This is a monorepo, so I have the app and the server here in the same repo. On the server, I start out by doing a create. This is a class I created. Let's dig into this a second. I do await here. This is actually just one of those things, like people ask for async constructors in Dart. No, you just create a top-level static, and you do await on it, which is great. And I glue some stuff together. So I'm not going to drill into all these APIs. I just want to give, again, a flavor of some of the things you can do. So one of the things is you don't necessarily want to hardwire in the name of your project ID, your Google Cloud project ID, into your code, right? Because you might deploy it somewhere else, you want to share the code with someone. So there's actually something provided by Google servers when you deploy, not just Cloud Run, but if you use Kubernetes, if you use Compute Engine, all of these things have a metadata server. And so you can actually hit this local metadata server on the running app when it's deployed and query all sorts of things about the type of runtime you're on, the CPU information, the project ID. There's information about the security keys if you want to use those, all from the metadata server. So I provide a helper here. This is in this Google Cloud package. And I handle all this work for you to go hit the metadata server. You see this HTTP. So this will only work if your code is deployed within Google Cloud somewhere. Again, Kubernetes, Cloud Run, Compute Engine. And depending on the URI you parse here, and this is well documented, you can go get the data you need. So in this case, I want to get the project ID. So I go get the project ID, so I know where I'm deployed. And then I create this API stub. And this actually is super nice too, and I'd recommend folks do this, which is if you're building an app, obviously I want to call backend APIs. From my server, I want to call into Firestore and update a value. Later, I'll talk about using Cloud Tasks and calling into that. Having this API stuff stubbed out somewhere else is great, because then you can write tests against it. You can write little CLI tools to verify your API's work without having to do server calls. So again, factoring out things is pretty good. So I do this little create thing in here. And here's another little bit of magic I'm going to talk about. So I want to call into these Google APIs I mentioned before, right? And part of what you want to do there is you need an authenticated client. So I want to call Firestore. I want to use my service credentials for Google Cloud, right? So of course you could include those credentials when you git push to GitHub, but you probably don't want to. You don't want that stuff on the cloud. You want those things on GitHub. So this is yet something else that uses that same metadata server under the covers. So this is an API provided by the Google API's auth package. And you'll see if you look up Google APIs, it comes here. And what this does is it does the right thing to go get the credentials for you. And so if you're on your local machine and you have the gcloud CLI command installed, go look at gcloud. It's a cool little API. It can go talk to that thing and get the credentials locally if you're logged into gcloud. But if you deploy this to Cloud Run or anywhere else that runs code in Google Cloud World, it'll go talk to the metadata server and say, get me the credentials there. So it'll actually get you the key information, that JSON information, from the metadata server. So you don't have to worry about deploying it or putting it in a secret or putting it in an environment variable. It just is there in the ether for you to use. So you actually have to do very little configuration to get that authenticated client. So this is the thing that my server app will use to call Firestore, Cloud Tasks, other things. And then just say, here's the scopes. So this client needs or wants to be able to talk to the data store API from Firestore and Cloud Tasks. And that's the stub. And then there's one final thing about JSON Web Tokens. And I just think this is interesting about how this all works, right? So I talked earlier about this JSON Web Token thing and how it's signed. So obviously I get a request in. I can go look, oh, here's a blob of JSON. When I decode it, here's the user. I want to make sure that's not spoofed. So I need to check the signature. So there's packages that support this already. It's called Jose. He's actually accepted some pull requests from me lately, which makes me very happy. It's a solid API. So it's interesting just in a web terms, like how this all works. So how do I go get the certificate? Well, it turns out, so my project ID is F3 2023. Let's just go dig into this real quick. I'm going to open up my browser, open a tab, F3 2023. It's this. This is very boring. This well-known URL. But you see this JWKS URI? That's where the certs are. So this document is HTTP served. It has an expiry header on it, right? So I know how often I need to go refresh it and check this again. I can go hit this URL with an M. Oops. Oh, it's so close. Just one second. And here's the public keys. I'll zoom in a little bit. So here's the keys. So again, I have all the source code for this. You don't have to worry about it or figure it out yourself. Just understanding this is how I go figure out what the public key is, and this is how I decode it. So I hand this over to my to this JSON Web Key store that Jose gives me, and this is the thing I use to verify requests. Just one second. So let's go back to my server, my handler. I can see I do some work to handle logging, go look at that, to handle caching and handling, and then my app server router. This is actually automatically generated for me. And in fact, we can go play with a simple example right now, increment. In fact, people that already were playing with this, we can go in here and go API/increment. Increment. So I have a very simple endpoint here that's just incrementing a value. In fact, if other people want to go to that initial app/API/increment, you can see every time I hit this, I'm actually running a transaction against Firestore and doing an atomic increment to that API. In fact, if I go to my little stub, you see the call here. So it's not the most straightforward code in the world to understand, but you can go read through and see like how you do a transaction in Firestore and actually call and use in the context of this and run an increment. So I know if 50 people hit this at the exact same time, I'll still make sure it's an atomic increment. And it looks like people are hitting it right now, which is great. But that's not the work that we want to talk about today. We want to talk about the update value call. So this is the call that I use when the app calls in and says, hey, update the value from the user. So the first thing I do is I go get the subject from the request. All this is the user ID. But the trick here is I actually do the work to say, oh, make sure that the token is real, like it doesn't have an error with it, and that it's verified. So I actually know the request came from a verified user. And I won't get into all the details now. You can go look and see how it works later. And I make sure the audience's request. So all this logic comes down to is like, oh, who is the user that made the call? So as a call, I don't have to add in the user ID. I don't have to trust the users tell me the right thing. If they have a signed token, I know it's real. And so I can go get the body from them, decode it, grab the value, and then I just do update value. And that's the API call. So this is the API call I'm making on my server to Firestore. You see I grab the JWT, which is basically just the user ID. All that is the user ID. And I update the value that the user gave me. Now this is the interesting bit, which is now that I have the value from the user and I've updated it, I now want to aggregate, right? I want to take all those little values that all the users gave and say, oh, what's the total count? What's the total average, min, max, everything else? I could do that inline in this request. Like the users made this request, I could go do that. But what does that mean? In the context of this request, I now need to go through and page through potentially dozens, hundreds of items in the Firestore database and do the aggregation. That means the user has to wait for that. And ideally, you want to return right away. So this is where I use Cloud Tasks. So instead of doing the aggregation right away, I queue up an aggregation using a Cloud Task call. So here I create a task request. I send it a request, say, hey, Cloud Tasks, go call the host, in this case, is my F3 host, API update aggregate, and I tell it what task to call. So basically, I've registered a task in a task queue. This is part of the Cloud Config API. And I say, just make an HTTP call for me to just update URI. That's it. And now I let Google Cloud call me back. So this is effectively doing things asynchronously. What's cool now is because it's in Cloud Tasks handles things like backoff and making sure that if the call fails, it'll try again in 2 seconds, and 4 seconds, and 8 seconds, where the fallback is. If it fails, you get a nice log information. And if you're smart about how you set this up, you can also set it up to do deduping to make sure that if 1,000 people are coming, maybe I just wait a second and then just do one update call for those 1,000 users instead of all 1,000 users all doing it as separate aggregation, right? Now, what's interesting, or you might wonder, is why is this useful? Because I'm just calling back to the same Cloud Run instance, right? I have one Cloud Run instance handling user calls and the service calls. This is actually one of the benefits of Dart. So we are, in general, single-threaded. There are ways to deploy cloud services or backend services that use multiple isolates. In this case, it doesn't really matter, even if you hit a single instance, single-threaded Cloud Run app, because we do concurrent I/O in Dart, which means we have many threads going on. We can have many concurrent operations happening at the same time. We have an event loop. And so I could be waiting for one cloud call or one backend call in one request and be handling another request at the same time. So even though the logic is single-threaded, you can still handle 50, 100, 200 users concurrently and still have really good performance. And if you look at I haven't profiled this directly. My guess is the vast majority of runtime time here is waiting for API calls. And so the fact that it's single-threaded really doesn't matter because I'm just waiting for, HTTP returns. So it works really well. So this is upgrade date aggregate method. Let's go look at that quick. So the first thing you notice is get another check. So guess what? When I go to Cloud Run and say, Cloud Task and say invoke a thing, and they call me back, they signed the request. And there's a bearer token in that with an authentication body. And I can go and check that. And if you look at the source code later, I just say, expect this to be a service request. And there's a little bit of a different signing key and different thing that I expect. And so I will make sure that I'm actually getting a request not from a Firebase user, but from a Google service account. And so anything, Cloud Tasks, Pub Sub, there's a bunch of these APIs at Google, they all use JSON Web Tokens. And so the authentication methods you used, even to verify end users, you can also use to verify services calling back into your APIs. Whether that's, I think Google Sheets has an API to do Cloud Run. You can verify, it's all JSON Web Tokens all the way down. So once you learn this set of tricks and how these things work, you can apply it across a bunch of stuff. So I get the request, and basically this request will fail if it's not from a user that I expect. I can do some logging stuff. This is actually part of that Google Cloud package that I mentioned earlier. Let me check my time. Oh, we're good. This is part of the Google Cloud package I mentioned earlier. What's really cool about using these logging methods, or even print in this context, if you use the APIs I provide, is I'll actually associate these logs with the origin request. So if you open up Google Cloud Logging, in fact, you just want to see cloud logging? Let's open it up. Console, cloud.google.com. And let me look at logging. I'll make the font a little bit bigger here, sorry. So you'll see this post, for instance. Let me close a couple of these sidebar things. Oh, wait, sorry, let me just figure out how to close some stuff. I know this is small on the bottom here. Which is that? Maybe not, sorry. Is that too low for people to see? Let me just go look at, oh, this is a good example. So here is the HTTP request that's coming in to my app, the post 200. And you can see that the logs associated with that request are actually aggregated underneath that post. So the request IDs are associated. So if I do a print or a debug log or a warning log, I actually can correlate the logs coming from my app, even a print actually we can capture and put in here, are captured with the request. So it's very easy to figure out, okay, what was the exact request associated with this log? And if you do the right wiring up around request IDs and other things, it just works. And so the pieces are all here to actually have a really nice cloud experience. So we talked about the aggregation, and actually let me make sure I cover the aggregation. Yeah, so I make sure I log the information about what the request is. And this is the other fun thing, and this is, again, what's kind of nice about layering some of these convenience things. So I added some extensions to the Firebase API. This one's called with transaction. And basically this says, in the context of this Lambda, I will give you a text, a string, which is a transaction. So this is just a very simple extension that I wrote. And so there's a model in Firestore. This is the server API in Google Cloud. There's a model for how you begin a transaction and say what kind of transaction you're going to do. It is a read-only transaction. And then go call that action, whatever the Lambda is. And if it works, return the result. And then I do a check on a success case. So that means there hasn't been an exception. I'll go and call commit. And I'll actually commit the transaction in Firestore. And if it fails, I'll do a rollback. Okay? So it's a very, what is that? 30 lines of code. But now what that means is, in this context, I can call with transaction against my documents. This is my Firestore documents. And now I can actually do a list all. And that's another helper. And then go list through every one of my events. And since it's in a transaction, I know these are all consistent, right? This is all in the context of one transaction. No users come in before or after. I know I'm looking at a consistent view of the database. I can list through all the elements. I can expand them out. I can grab the value. And then I can pass it to this light stats API I have. And this gives me average, max, min, and count. And then I can write that summary to Firebase. And so, in fact, if you go into Firebase, into settings, summary, you'll see, here's the average. And so someone's still playing with it. Someone move around the slider for me. Anybody? Do I have to go do it myself? I can do it myself. 5, oh, there we go. Thank you. Someone moved the counter for me. So that transaction does the aggregation, and it writes a Firestore. And then what's great is now I have the data back into Firestore. I can just bind to it. And so that's the value you get here. That makes sense? So I'm using Cloud Run to listen for an event. I'm using package Jose with some helpers to decode the JSON Web Tokens from the user, verify they're valid with the right signatures. Then I can write to the user's value. So as I click on this value up here is actually the user value. So every time I click here, this is a API call, HTTP post back to Cloud Run. Cloud Run calls Firestore, updates Firestore. The WebSocket locally in the browser sees the write back. So that's all happening right away. And then this thing, every time I click also, I'm making a call from that backend to Cloud Tasks. Cloud Tasks then calls back to Cloud Run, does an aggregation, write, update, writes those values, and that's a post back. And you see how fast it is. There's like 6 API calls there, and then it's super snappy. And it scales out arbitrarily, right? Because this is all serverless technology. Cool stuff? Kind of get it? Again, you won't get it all today, and that's fine, but these are the pieces you can use to build these solutions. So we talked about this, Cloud Tasks. So it's async and it's event-driven, which is super nice. We can do that super fast user update because we just defer it till later to go do the aggregation. And then, in theory, you have an opportunity for smart aggregation here. If you want to be really clever on the server, what you could do is, every time an update happens, have a future. It's I'm going to wait 1 second locally to do an aggregation and check to see if the future is null. And if it's not null, there's already an aggregation queued up, and you just don't do another aggregation locally. And then, per instance of Cloud Run, there's many fewer calls back to Cloud Tasks, for instance. So there's some opportunities to be efficient in terms of how often you do aggregation. Because again, if you have 10,000 users, you don't need to do 10,000 aggregations a second. Do 1 aggregation a second, right? You want to be smart about how you do that. So that was way 1. Cloud Run, HTTP post, super nice. The other way, which I didn't want to get into because it gets more complicated, is using a new technology called EventArc. So this URL with Firestore. Oops, I'm going to click on this first. Firestore, and actually Firebase in general, for a number of APIs, now supports sending events via EventArc. So EventArc is a new standard coming out. EventArc is Google's implementation. There's a functions framework and a cloud eventing model that it's based on. And it's a standard way to handle eventing across the web. And the idea is, if you make handlers that follow this convention, you should be able to integrate with any cloud provider. And so it's trying to standardize the schemas, the headers, everything for how we do asynchronous eventing on the web, which is super nice and long overdue. So let's go to the console. So if I go into here, EventArc, hopefully the font size is big enough here. We can create a trigger. I'm not going to finish this. I'm just going to show you how it works. Is this font big enough? So F3 something, Google source, and I can go in here and go Firestore. And I can say, I want the data entry updated event. And what you'll see here is the event type is protobuf. So we'll get into this in a second about hand of protobuf. We're now in a world that's a little bit more complicated than JSON, but in theory, it should be pretty nice. So I can say what database I want to. So again, this is the region thing that's really important. Right now, it's only supported in certain regions. You want to make sure that you pick regions that support this thing. So right now, it's these. North America 5 is the big one. You can say, I want it on this database. You can actually go in here and say, be more specific. I want this key or this range of keys to be the thing I trigger on. And in those cases, if that key's updated, call a function. And then you just put the URL. So you say what Cloud Run instance and the URL you route to. And you'll get these events from EventArc for updates. So now you're starting to see this is within a rounding error of what you can get with Cloud Functions. You can now listen to a number of events from Firebase, not just Firestore, Firebase, and handle those without having to do these HTTP calls, which is really nice. And in fact, I'm going to show really quick. There's a sample I have. If you go to the functions framework repo, you'd probably be better off starting on the package site and finding the URL. It's like under Google Cloud something. I have a sample for how this works. And so if you go into examples, protobuf Firestore, I have a sample here that actually handles the event. And there's just a standard event class. But I can actually go to the data. I know it's binary data. And I can create a document event data from that buffer. And that gives me a nice, strongly typed Dart object for that protobuf information. And I can do interesting things there. I can return it, or I can print out the content of it. This is all APIs that are all updated from publicly available protobufs. I don't quite have a story yet for generating these classes automatically, but this package at least shows an example of how you can get access to all these event types and use them. Find me on Twitter, file issues. I'm happy to engage if people want to go and make a better access API for these things. But these are all Dart classes generated from well-defined, publicly available protobufs from Google stuff. And it works great. Where'd my slide go? Here we go. So this is the functions framework package that supports some of this. Again, don't get confused. So many people have gotten so excited. They're like, oh, the functions are here. Like, no, this is not Cloud Functions. This is a different functions thing. But there's some cool stuff for code generation here to handle events as well. And I'm happy to engage people with questions there. So keep in mind, this is a preview. This EventArc support for Firebase is preview. What's really nice about this is you can keep the original client implementation in Firestore. You just write to the entry. You don't have to do this HTTP post thing, which is really great. Most Firestore events are supported. And then obviously the existing, I said pub sub here, but it's cloud tasks, but the same backend support will work. Like you handle the event using EventArc, and then you can do the same aggregation stuff from that logic. And so the question might be, which one do I use, right? So the hosting-based support, the first thing I covered, that's Cloud Run, that's fully supported. What's really nice is you can fully control what gets written. And I think for many cases, if you're doing games or things where you worry about people hacking code, again, it's all, especially browser apps, right? Anyone can kind of figure it out or hack the request model. You can have full control over what gets written, which is really nice. So if you're doing a game, you want to do turn-based stuff, having the server intercept every update to Cloud Run, or sorry, to Firestore is really great. You can lock down all of Firestore and just allow write access for the things that users need. And you don't have to deal with protobuf parsing, which is a little gnarly. The one nice thing about the EventArc-based thing is that you can leverage the client-side caching that Firebase offers. In fact, I don't know if people noticed in the app. Let's see if I can get it to dance. If you drag this around, oh, there we go. So I'm sending events all the time, and I'm updating it locally, but then the event from the server gets updated and written back, and then it changes where the value gets sent, and you get in these weird cases where like it gets a little bit of a mind of its own. It was doing way more in development. Oh, there you go. It gets a little weird. So of course, Firestore, the client that you use locally, handles all that, debouncing and making sure the sync works well. So not having to worry about that can also be really nice. That might be a reason why you want to use the EventArc-based thing. Just keep in mind, it's a preview. So there's the app to go play with. Not very exciting. It's tricky. I want to make an interesting interactive app where it doesn't use any authentication, where I get no personally identifiable information from anybody here, so it has to be anonymous, and do a scenario where no one can do anything inappropriate. So I'm like, slider, I challenge you to do something inappropriate with a slider. I'm sure some of you will figure it out. So I'd encourage here, I was so excited to do a backend focused talk. I can use, mono width spaced fonts. And it's not super pretty, but it's a lot of interesting technology. So I encourage you folks to look at the source. I'll have the link here in a second. Fork it, send me PRs, talk to me, find me on Twitter. I'm happy to engage. And keep in mind, we're trying to build momentum about Dart on the server. Our team doesn't have a lot of time to support this because we're very focused on Flutter, which I'm sure most of you want us to be focused on. But there is an opportunity here to grow the community. And the more that folks like in Google Cloud see that people are interested in using Dart on the back end, the more support we get from them. And I think there's a nice positive loop to happen there. So there's the app to play with, the most exciting web app you've seen today. The source code is here, fast and slow if you want to play with it. I think I've done an okay job of removing some of the secrets and one-off values. I need to do some more cleanup, but it'll evolve. I'll keep updating the source code. And again, if you want to find me anywhere on the internet, all my previous talks, and this talk, when it's posted, will all be on my vanity domain. So that's all I have, and I'm excited to take questions. Thank you.